Hello viewers, in today's lecture we are going to take up one important form of the equation of a plane that is perpendicular to a given vector and passing through a given point, right? In our earlier video we have discussed the normal form of the equation of a plane. So let us start. Suppose this is a system of mutually perpendicular axes, and let pi be a plane, right? And suppose this plane is perpendicular to a vector, say this is the vector n, right? And this vector is known as the normal vector to the plane, right? So this plane is perpendicular to this vector. Now suppose this plane passes through a point, say A, and this point A has coordinates x1, y1 and z1, right? So this plane passes through a given point. So the given point is the point A, and the perpendicular to a given vector is the vector n, right? Okay, so n vector is the given vector, right? And this is the origin. Now the position vector of this point A is OA, and OA can be written as say this is vector A, and we have x1 I cap plus y1 j cap plus z1 k cap, right? Okay, now let us take a point P on the plane, and this point P is a general point, and the position vector of this point P is vector OP, and this is xi cap plus yj cap plus zk cap, right? Now let us join OP, and this is our OP vector, right? So this is vector A, and let us say this vector is R, right? This is vector R. Now if we join AP, then the vector AP can be written as position vector of point P and minus position vector of point A, right? This can be written as OP minus vector OA, and OP is vector R and OA is vector A, right? Okay, now we see that this vector n is perpendicular to the plane, so therefore vector n is also perpendicular to the vector AP, right? So this implies that AP dot vector n is equal to 0, because the dot product of any two perpendicular vectors is always 0, right? So if vector A is perpendicular to vector B, then A dot B must be 0, right? Okay, so AP dot vector n is 0, and let us substitute the value of vector AP as vector r minus vector a dot vector n equal to 0, right? So viewers, this is the vector equation of a plane that is perpendicular to a given vector and passing through a given point. So this is the vector equation. Now let us find the Cartesian equation. Now this vector r minus vector a can be written as xi cap minus plus yj cap plus zk cap. This is vector r minus vector a is your x1 I cap plus y1 j cap plus z1 k cap, right? And this is equal to it is the dot product of vector r minus vector a with vector n, and let us take vector n as ai cap plus bj cap plus ck cap, right? In other words, we can say that the direction ratios of the normal to the plane are a, b and c, right? So here we have the dot product, so we can write it here, or we can write it like this. This is ai cap plus bj cap plus ck cap, right? And it is equal to 0. Now if we simplify these two vectors, that is, if we write it is as x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap, right? And this is the dot product is taken with ai cap plus bj cap plus ck cap, right? That is equal to 0. Now if we take the dot product, then we have x minus x1 a, because when we take the dot product of two vectors, then we multiply the x components and y components and z components, and the products are added. So here we have x minus x1 times a, y minus y1 times b plus z minus z1 times c is equal to 0. So this is the Cartesian equation of a plane that is perpendicular to a given vector n and passing through a given point a, right? Now viewers, let us take this problem. Find the vector and Cartesian equation of the plane which passes through the point. See, the plane passes through this point, so it means this is the point A, right? This is the point A, and the point A is x1 comma y1 comma z1, right? And it is perpendicular to the line with direction ratios 2, 3 and minus 1, right? So we have to find here the vector and Cartesian equation. So here we are given the vector A, that is 5i cap plus 2j cap minus 4k cap, and the normal vector n perpendicular to the plane as the vector n is given as 2i cap plus 3j cap minus k cap, right? So here we are given the point A and the normal vector. Here the line is, or the plane is perpendicular to the line, so the direction ratios of the normal are also 2, 3 and minus 1, right? So here we are given these two vectors, and now we have the vector equation as vector r minus vector a dot vector n is equal to 0, right? So we have vector r minus vector a is given as 5i cap plus 2j minus 4k, and the dot product is taken with the vector n, and here we have 2i cap plus 3j cap minus k cap equal to 0. So this is the vector equation, and let us find the Cartesian equation, and the Cartesian equation is x minus x1 a plus y minus y1 b plus z minus z1 c equal to 0, right? So this is the Cartesian equation of a plane which passes through the point x1, y1 and z1, and the direction ratios of the normal to the plane are a, b and c. So here we have x minus x1, y1, z1 are 5, 2 and minus 4, so we have x minus 5, and a is 2 plus y minus 2, b is 3, and z minus z1, z1 is minus 4, so here we have plus 4, and c is minus 1, right, equal to 0. Now if we simplify it, we have 2x minus 10 plus 3y minus 6 minus z minus 4 equal to 0. So this is 2x plus 3y minus z, and this is minus 20, right? This is equal to 0. So this is the Cartesian equation. Now viewers, let us take this problem. Here we have to find the Cartesian and vector equation of a plane which passes through the point 1, 2, 3 and perpendicular to the line x minus 1 by 2 equal to y plus 2 by 3 equal to z divided by minus 3. Now here we are given the point. This is actually point A, and this is x1, y1, z1, and the plane is perpendicular to the line, and the drs of the line are 2, 3 and minus 3, right? So the plane, this is our plane, and this plane is perpendicular to the line, and the line is parallel to our normal vector. So the drs of the normal vector are proportional to 2, 3 and minus 3, right? So the Cartesian equation can be written as x minus x1 a plus y minus y1 b plus z minus z1 c equal to 0. Now here x1, y1 and z1 is the point 1, 2 and 3, and a, b, c are 2, 3 and minus 3, right? Because the normal is parallel to the line, right? So we have x minus 1, and here we have 2, then we have y minus 2 times 3, and here we have z minus 3, and here we have minus 3, that is equal to 0. Now if we solve it, we have 2x minus 2, then we have 3y minus 6 and minus 3z plus 9 equal to 0. Now we can write it as 2x plus 3y minus 3z, and this is minus 8, minus 2 and minus 6 is minus 8 plus 9, that is 1, right, equal to 0. So this is the Cartesian equation of this plane. Now for finding out the vector equation is given by vector r minus vector a and dot vector n equal to 0. So here we have vector r minus vector a is given by this point. So we have I cap plus 2j cap plus 3k cap, and here we have to take the dot product with vector n, and vector n can be written as 2i cap plus 3j cap minus 3k cap equal to 0. Why? Because the plane is perpendicular to this line, and the line has direction ratios 2, 3 and minus 3, and our line is parallel to the normal vector. So the drs of the normal vector are proportional to 2, 3 and minus 3. Therefore the vector n can be expressed as 2i cap plus 3j cap and minus 3k cap, right? And that's why we have substituted the value of vector n as this vector. Clear? So this is the vector equation of this plane.